All right. Remember how we had your sheet when we talked about your functions and I made you keep your domain and everything else, your max and your mins? You're going to keep this sheet handy as well. This is what's going to help you describe your rational functions. Again, you find your intercepts the exact same way. We find our intercepts, our y-intercepts, when we set x to 0. We find our x-intercept when y is the 0 of the numerator. Put a little star next to this. This is your zeros of your numerator. Okay? And we do a couple of days worth of this, so I kind of do it step by step. You didn't get one, honey? Right there. One of each.
I got it.
You got that one? Okay, sorry about that. We look at your vertical asymptotes. The vertical one, that's when you have a restriction in your denominator. This is because of a restriction in your denominator. But we're going to look at that after we factor. Now you see this is bold. After factoring and reducing, we look at the zeros of your denominator. Tomorrow's part is after we factor and we actually reduce that factor becomes a point of discontinuity, which is at the bottom of that page. So, God bless you. So tomorrow we'll do the point of discontinuity, not today. But just so that you know that it's coming, when we take out a factor from the numerator and the denominator, that x value becomes a point of discontinuity. What happens is, it looks like your graph is going right over it, but it's open. Because you can't use it, it's still in the denominator. But it doesn't affect the asymptote part of it. So tomorrow we hit that. Now, your graph cannot cross your vertical asymptotes. This is another important thing. Once you make your asymptotes, and if you remember from before, like this, usually we saw something that went like this. We saw it go like this. It can never cross this vertical asymptote because this vertical asymptote comes from your denominator. So that it will never cross. However, a horizontal asymptote, it can jump. So the horizontal asymptotes are the guys that go like this, across. Yeah. In a horizontal asymptote, we have a series of steps to see what our asymptote is. And we look at the degree, the highest degree in your numerator versus the highest degree in your denominator. We're going to walk through one so that you can totally see it, but I want to go through step by step what you should expect. We're going to check your degree in the numerator. For instance, say this is x to the third plus blah, blah, blah. This is x squared minus da, da, da. We look at the highest exponent, and we say, if the degree in the numerator is less than the degree in the denominator, this is what we're looking at. Then you have a horizontal asymptote at your x-axis, where your y is 0. If your degrees are equal, you have a horizontal asymptote when you take your coefficients and you set this is the a, this is the b. When the degree in the numerator is greater than the degree in the denominator, you have no horizontal asymptote. But tomorrow, we will check for a slant asymptote. So today, we're just going to talk the basic parts. Tomorrow, we're going to embellish a little bit more. We still have our domain and range. We still have our max and mins. We still have our increasing, decreasings. We still have our concavities. They work the same. Now, a graph that looks like this, say, for instance, it's going like this, just for instance, this has no max or min. Because what happens is, this is kind of leveling out here. It's going up like that. It's going down this way towards the x-axis. We're going to see its end behaviors. So it has no max or min here. They do, however, consider this concavity. So we'll talk concavity when we do that. But in these cases, there may be no max and mins. But we do have increasing, decreasing. This guy is a decreasing y, isn't it? You can't see it, and in your calculator, when you graph these, it has a habit of stopping at that line. It doesn't stop. When we look at an asymptote, it rides right along the asymptote, and it sometimes jumps over it. But when we do this, we'll realize where our asymptotes are. It gets closer and closer and closer to this. So technically, this is constantly a decreasing over here. This also happens to be a decreasing part over here. Y is decreasing as X is moving. So we do have increasing decreasings even without a max and a min. Okay? So that we'll get to as we go through this. Also, tomorrow, we'll be talking about your point of discontinuity and your plant asymptote. That will throw in tomorrow. Today, I just want to talk basic graph. The big key thing here is the factoring. Every time we set one of these up, we factor. If we can reduce a factor, we're going to get a point of discontinuity. If we can't reduce a factor, there's no point of discontinuity. We'll just keep on going with this. So let's try one of these and see what I'm talking about. We're going to sketch and describe this. Now, kindly put this in your y equals and take a look at this. What's going to cause this not to be a continuous function? Kyle, where? What did you say what's going to cause this? The denominator. And what's wrong with the denominator? It cannot be what? The denominator cannot be 0. Your x in the denominator cannot be 0. Your denominator rule always holds. Your denominator cannot be 0. So it can't possibly use that x of 0. So if you look, after you graph this at your table, where x is 0, what does it say? Error. It can't use that. So that's what stops this from being continuous. It's going to have to jump over that x-axis. And we're going to see something else happen to it as well. So you kind of see something that kind of looks like this right now. It goes like this, right? And then it goes something like this. Agree? Now, this is the guy that's causing your domain. We say, the domain cannot be equal to 0. So when x is 0, we have a problem. So your domain says all real numbers except the 0. So we take that out of our domain. Remember taking out your restrictions out of your domain? I'm saying, oh no, not this again. Alright, so we've got a restricted domain. Can we factor this? Don't tell me cross out an X. No, no, no. Can't be factored, right? You can't cross out that X. So this can't be factored. So in going through your sheet, keep your sheet handy. We're going to work on your asymptotes. We're going to do your intercepts in a minute. We're going to work on your asymptotes. Keep your sheet handy. I'm keeping mine here so I can try to follow yours so that I'm not jumping around. Vertical asymptote. Vertical asymptote says, after factoring, which we couldn't, and reducing the zeros in the denominator, which we can't, you can have one, none, or several. So you're going to take this guy, and you're going to set this equal to 0. These are the zeros of your denominator. These are the zeros of your denominator. Right now, you just have one little x in here. So you have an asymptote where x is 0. Now let's look at your graph, your sketch, and see if it fits in. Your vertical asymptote is a line, a vertical line. When x is 0, it's right here. Ah, that makes sense, right? It's not allowed to cross that. So it gives that like a barrier. Like your asymptote acts like a barrier. And that's where your ends are going to behave. So this end up here keeps traveling along, and never touches it. Right? That's what your asymptote does. Now, next step, we're going to look at your horizontal asymptote. Your horizontal asymptote says you need to determine your end behavior for your graphs to see where your lines are going, these guys. See where they are. Now, we look at the highest exponent in the numerator and the highest exponent in the denominator. What's the highest exponent in the numerator? 1. And the highest exponent in the denominator? 1. So if you follow your sheet, it says the degree of the numerator is equal to the degree of the denominator. Then you get a line, y equals a over b. These are your coefficients. So there's your a, and there's your b. See it? So y is equal to 4 over 1. So my asymptote says y is equal to 4. Now, wouldn't that be right here? Looks like it, right? There's your other asymptote. Now what it does is, it also says, okay, these ends are going to go along, but never touch that. It's my barrier. This end is going to travel along, and never touch that. We may see an instance or two where it actually jumps over the horizontal asymptote. And if this is my horizontal asymptote, my graph will go like this, jump, but then come like right along it. So it'll jump, but it still helps my ends behave. It tells me where they're going. It's traveling along that line. So we found your horizontal asymptotes. Good so far? Pretty much this tells us a lot about our graph. The one other major part are any of your intercepts, your x and your y intercepts. Do we have a y-intercept here? No, because we can't make x be 0, right? What happens for our y-intercept? When x is 0, I've got 4 times 0 plus 1 over 0. Can I do 1 over 0? No. So I have no real y-intercept. And that makes sense, because my asymptote is when x is equal to 0. So you can't use an x of 0, right? And your calculator says error. Now, my x-intercept, and I do see one here. I do see one x-intercept right there. My x-intercept says let y equal 0. Now, just solve. Just solve for x. You just take your y. This is the same as your y, f of x. Oops, I forgot my denominator. Take your y, set that equal to 0. Cross multiply this. Subtract the 1. And divide by 4. So when x is equal to negative 1/4, y is equal to 0. Now, check that in your calculator, because it's so close, you might not see it. It might look like it practically stops at that axis. And your graph, can I borrow your graph? Did you graph it? Yeah. See how it looks like it kind of stops at that axis? It really doesn't. It really keeps on going. Now, let's check that. Do a second calc, number 1 value, and put in x is equal to negative 1/4. It should say y is equal to 0. Your calculator looks like it goes like this. It looks like it stops there, but it really doesn't. It just can't get any more exact than that. And if you took a point, say you did a value and you did x equals negative 0.002, you would find your y value. It's just that your calculator can't get any more exact. Our sketches, we make it so that at least we know where our end behaviors are going. Don't make your sketch to look exactly like your graph on your calculator, because your graph doesn't really do it what you want it to look like. Okay, now this guy has no max and no min. Because of the way it's shaped, it has no max or a min. We have no max, no min. Okay? All I want you to do, guys, is walk through the sheet with me. We're going to stop at the point of discontinuity today. We're not doing that part, but we've got all these other parts that we have to go through. Now, we're looking at concavities. Let's do increasing, decreasing first. You're following for x from negative infinity to infinity. So here's your graph. From negative infinity, as I travel this way, what's my y doing? Decreasing. So I have a decreasing function from negative infinity to where? To the 0. It can't go past the 0. Then I start up here, and what's my y doing? Decreasing. From where? 0 to infinity. Okay? I have no increasing parts. No increasings on this, just a decreasing. Now, your concavities should follow the same way that your increasing decreasings do. This technically, this guy here technically makes the cave down. See the downward motion? Down. There's your cave down. So I'd have a concave down, no increasing. From negative infinity to 0. This guy technically makes a concave up. It doesn't look it because this keeps on going closer and closer, but it technically makes the cave up. So this is concave up from 0 to infinity. And I think we told everything about this. How about your range? We didn't do your range. We did your domain. Now we're going to go back and do your range. Your range is tricky. What values of y could you not use in this graph? 4 and 0, right? Did I ever touch the 0? Because that x couldn't be 0, my y couldn't be 0, but do I still pass up this way, like this? Do I still increase past the 0? So my range has no effect on this one. Even though my x, I'm not using that point, and that's fine. My x value says don't use that, but my y value says, look, take this guy. Oh, I didn't plan on that one guy moving. Take this guy and go past the 0. So technically, I passed a y of 0. So I'm okay here. The only y I can't use is this one. So let's take that out of your range. Negative infinity to where? 4, good. And then 4 to infinity. Okay. Your y still travels past that. It did hit a y of 0, even though your x 0, 0, that's not there, that's fine. Just your x couldn't use the 0. When we hit the point of discontinuity, then we have another point to worry about. But right now we're just doing your basic graph. So we told a lot about this graph. Agree? I kind of like you here. These are really your zeros of your numerator. And all we have to do is look at your numerator. It didn't matter. Today I kind of wanted to show you that it works like your old one works because we had nothing to factor out. All right. Ready to try another one? All right, one more. Okay. First of all, can I factor anything up here? Always go for the factoring. I can factor this, perfect squares. Right? Can I reduce anything? No. So, let's go for your domain. You can always do your domain once you see your denominator, but you can't do your range yet until you see what y's you have from your asymptote. So let's do your domain. The denominator cannot be 0. So what values of x can we not use? 1 and negative 1. Good. So let's take that out of our domain. So, negative infinity to negative 1. Don't forget the negative 1 to 1 and 1 to infinity. Save your range for later. If we're not able to factor, that also becomes your asymptotes, that 1 and -1. If we're not able to factor it. If we are able to factor it, tomorrow we'll see it becomes a point of discontinuity. But today we can't factor it. So let's jump down to your asymptotes. I think asymptotes are important before you start to sketch your graph, because you want to kind of lay out your asymptotes so you can see where your graph goes. Now, your vertical asymptotes, these are the zeros of your denominator after you factor. And since we couldn't factor, we know, God bless you, that there's our two asymptotes at x is 1 and x is -1. Let's lay out your asymptotes, and then when we graph this, we can kind of figure out where we should put it down. Let's do your horizontal asymptote. Your horizontal asymptote says, look at your exponents. Your exponent in your numerator is a 1. Your exponent in your denominator is a 2. So go to your sheet. When the degree of the numerator is less than the degree of the denominator, you have an asymptote at y equals 0. That's your x-axis. So your degree in the numerator is less than your degree in the denominator. So you have one asymptote here. This is along your x-axis. Along your x-axis, y is equal to 0. So let's see if we could sketch your curve. We know two things, your verticals and your horizontals. This is x equals -1. This is x equals 1. And this is y equals 0. Now, I don't expect you to figure out where it gets placed. Put it in your calculator. Now you can take that picture and kind of impose it onto this graph. So when you graph this, graph it in your calculator. And you should see a graph that goes like this. Let's go through the 0. Okay, do you see this? That once you put your asymptotes down on your paper, it helps you to put your graph on there. Otherwise, you're trying to figure out where the heck should I go over this thing? Like, where am I not supposed to cross? Okay. Now, do you see this right here, this red one? This red one in the middle? Do you see how it jumped over this asymptote here? It jumped over that asymptote. You can jump a horizontal, but you can never jump a vertical because that's the denominator restriction. That's your domain restriction. But you can cross over a horizontal one. The horizontal ones are there just to guide your end behaviors. And so doesn't it make this end behavior behave down here and this one behave over here? Your asymptotes are like your barriers. If you're driving along the street and there's a barrier, you're certainly not going to cross over that. You can drive real close to it, take a chance, but you can't cross over it. The only one you can cross is your horizontal. So let's finish this guy up. Let's do your x-intercepts. These are the zeros of your numerator. That's when you find out if you have a turn. Hello, Mrs. Moore. Hi. Sure. Oh. Oh my gosh. Oh, okay, no problem. Thank you. Thank you, bye. Nina's bus refused to pick her up because it was too slippery. Did anybody have that problem today? Did anybody's bus not come? Oh, that's crazy. Okay, let's do your zeros of your numerators, guys. So 3x is equal to 0. Therefore, what is x equal to? 0. Ah, Did I intercept right here at the 0, 0? Mm-hmm. And we can see it intercept. Let's do your y-intercept. When x is equal to 0. You're best like just going back through your original equation. So y is equal to 3. And you know, I realize you can tell what it is, but you still have to put it in here. So you've got 0 over -1. And that is a 0. So there's your y-intercept. And can you confirm that you crossed at the 0, 0? You should be able to confirm this. You should be able to look at your calc and see what it's missing. Now, again, there's no min, there's no max on this. But there's increasing, decreasing. What's the value of y doing as x is increasing? Just grab one of these from -infinity to -1. So you're decreasing from -infinity to -1. What's it doing here in the middle? Increasing or decreasing? Decreasing. So you're decreasing between -1 and 1. And what's it doing on this side? Decreasing. Okay. So from that, thank you. From that, you should be able to find your concavity too. Your concavity says, this is my page down, from -infinity to where? -1. And what's this one over here? Gave up from where? 1 to infinity. And this guy in the middle, no concavity. Technically, he's got an inflection point there. This is the point where it inflects. It was turning up, it was turning down, and it inflected over there. It does kind of have an inflection point, but we're not going to worry about that on this graph. Questions? When you do those tonight, make sure you sit with this sheet next to you. You've got to go through this. It's the one thing that's going to help. I don't expect you to memorize.